In this video, we're going to learn to write and balance chemical equations. We're going to start with a chemical statement. Aluminum and sulfuric acid react to produce aluminum sulfate and hydrogen. To convert that to a chemical equation, we're going to turn the aluminum into the symbol for aluminum plus and sulfuric acid, H2SO4, react to produce, that's our arrow, aluminum sulfate and hydrogen. As we can see here, now we have a chemical equation, and we can start looking at balancing this chemical equation. Let's step back for just 1 second. Aluminum and hydrogen, why do we put the aluminum as Al? Well, we know in its elemental form it's going to just be by itself. So why is hydrogen H2? Hydrogen is a diatomic element, and therefore in its atomic form needs to be H2. Sulfuric acid, that's one of the acids that you need to know its common name, H2SO4. So how about aluminum sulfate? What if you did not know the structure for aluminum sulfate? Well, we can figure that out by looking at aluminum, which has a normal cationic charge of 3+, and sulfate, which we know has a charge of -2. We need the charges to balance. Since this is an ionic compound, to balance, we're going to have 2 aluminums and 3 sulfates. Balancing a chemical equation means balancing the elements on both sides of the reaction. The elements in the reactants need to balance with the elements in the products. This is mostly trial and error, but we can use a few hints. First hint, work on balancing the coefficients for the compounds before the coefficients for the elements. Second, treat the polyatomic ions that appear on both sides of the equation as a unit, not the separate elements. And third, count atoms and or polyatomic ions carefully and every time you make a change. So if we're going to balance this equation, we start by leaving a space for the coefficients, and then we're going to count up each of our elements or polyatomics. Notice that we have sulfate on each side, therefore we can use the polyatomic ion instead of the elements. That means we have aluminum, hydrogen, and the sulfate. To balance, we'll start by counting on each side. On the first side, assuming that all of our coefficients are 1, we have 1, 2, and then 1 sulfate. On the product side, we have 2 aluminum, 2 hydrogens, and we have 3 sulfates. Now remember, we want to start with compounds first. So I'm going to skip aluminum for right now, and let's look at our more complex systems, which is going to be our sulfate. So we're going to need to create 3 on one side. I'm going to do that. Put 3 sulfuric acids. That means that we change each of our quantities here. We now have our sulfates balanced. Now our hydrogens are out of balance. And if we notice, our hydrogen and aluminum are both elements. So we can move to these. To balance hydrogen, we're going to need a 3 in front of the hydrogen to balance our hydrogens. And now all that left is the aluminum. So we need a 2 in front of the aluminum to balance. And now we have a balanced chemical equation. Of course, we did not put the coefficient in for aluminum sulfate. And since there's not a coefficient there, it's assumed to be 1. But we do not have to draw the 1 when we're writing the chemical equation. We've now balanced this equation. It's often trial and error, but if you use the same system every time, it'll keep you from making a simple mistake. Let's look at another example and try and balance this chemical equation. Calcium nitrate reacts with water to give us calcium hydroxide and ammonia. Again, let's look at what we have. In this case, no polyatomics, so we'll have to start with our elements. So calcium, nitrogen, hydrogen, and oxygen. On the other side, same elements. Okay, we start by counting. We have 3 calcium, 2 nitrogen, 2 hydrogens, and 1 oxygen. On the other side, we have 1. Now, the hydroxide is in parentheses, so that means both of these get multiplied. So we have 2 oxygens. But on the hydrogen, we have 2 here, and we have 3 there, so that gives us 5, and then 1 nitrogen. Let's start with calcium. We're going to convert the calcium here. Put a 3 in front of calcium. That gives us 3, but it also changes our oxygens and our hydrogens. We have 2 oxygens times 3. That's going to give us 6. We have 2 hydrogens here times 3, that's 6. plus 3, that changes it to 9. So now our calciums are balanced. Let's balance nitrogen. We have 2 nitrogens, so we're going to need at least a 2 here. That converts this to 2. 2 times 3 hydrogens, that gives us 6 hydrogens, plus the 6 from the calcium hydroxide, that gives us 12. Now our calcium and our nitrogen are balanced. We need to balance our hydrogen and oxygen. If you notice, we have 12 to 6. That is a 2-to-1 ratio, which means all we need to do is put a coefficient in front of our water to balance the equation. So 12/6, that means we're going to need 6. That's going to convert this to 12, that to 6, and now we have a balanced chemical equation. And again, we could put a 1 in front of the calcium nitrate just to show that it has a coefficient 1, but again, coefficients of 1 are left blank.